For the past 2 years, I've been investigating the emergence and spread of nightmare bacteria. Superbugs that are increasingly resistant to even the strongest antibiotics.
The bacteria are fighting back and they're defeating the drug.
Correct.
I've been tracking the phenomenon through hospitals around the country, where doctors have been dealing with patients infected by these superbugs, which go by names like KPC and NDM1.
All these R's mean that the bacteria is resistant to that antibiotic.
I'd found outbreaks that have paralyzed some of our best hospitals.
And no matter what we did, the bacteria was still spreading.
More than 20,000 people a year are dying from these infections, and as many as 2 million get sick from them. What's become apparent is that these nightmare infections are being fueled by the overuse of antibiotics, creating bugs we can't kill. But the more I looked into it, the more I saw there was another dimension to the story. It turns out most antibiotics aren't even used by humans. They're used on farms. Getting onto a farm wasn't easy. The use of antibiotics in agriculture has become such a sensitive subject that most farms won't let cameras in. But one in North Georgia agreed, as long as we didn't reveal its name.
What's your big goal?
The farm's veterinarian, Chuck Hoffaker, showed me how antibiotics have become essential to industrial-scale farming.
My big goal is to prevent disease, and that's what almost all food animal veterinarians today focus more on: stopping disease introduction, preventing diseases from happening, rather than having sick chickens and animals that are suffering. There's a light switch here somewhere. I'm looking at trying to prevent any health issues in this small city of chickens of 100,000.
It is like a small city, isn't it?
Yes, because once they get sick, just as in a city, the disease can then spread through the population fairly quickly.
This is what Hoffaker wants to prevent.
This chicken was sick because of an intestinal disease.
So this is a signal to you that time to use an antibiotic to prevent this from spreading.
That's correct.
Chuck, what do we have here?
Well, this is an antibiotic called lincomycin.
Antibiotics like this are regularly put in the drinking water or added to the feed of healthy animals, most of the time without a prescription.
Empty the antibiotic into the water. Water coming out of this bucket with the antibiotic will be injected into their water, and then that water will then go on into the chicken house and will be at the proper dosage.
It's estimated that as much as 70% of all antibiotics sold in the United States go to farms.
They drink out of these nipples, and they eat from these feeders, and that helps the flock grow better. The farmer does better because they have more pounds of meat. Give the consumer a cheaper food supply. The chickens are healthier, so healthy chickens mean a healthier product for the consumer as well.
But increasingly, this widespread use of antibiotics in animals has been raising concerns.
Is it possible that there's a pathway? I'm thinking particularly of resistance, could it go in bugs from the chicken house to the family table?
We don't know how often that occurs. We think that it probably occurs at a very, very low rate. That linkage is very difficult to connect the dots.
Scientists have long been looking for connections between these dots, trying to understand whether the use of antibiotics on farms is contributing to antibiotic resistance that threatens the health of people. As I dug in, I began to find new evidence that was complicated and surprising. My investigation took me to Flagstaff, Arizona, where I'd heard about some of the newest research being done. Flagstaff's hospital has seen a rise in urinary tract infections that are increasingly resistant to antibiotics.
Okay, we have the lady in room 12. She came in 2 days ago with the E. coli in her urine.
Right.
What came back this morning as being a resistant organism, so we had changed from Zosyn to a carbapenem.
These infections strike an estimated 8 million Americans every year. Like in Flagstaff, doctors around the country are struggling to treat them.
Looks like it's only preliminary, but it looks like it's a gram-negative rod. We're seeing a lot more patients that were previously normally healthy have to be admitted because they've gone through multiple outpatient courses of antibiotics. They haven't improved, and at the point that they come in, that bacteria has gone into their bloodstream, and that requires immediate hospitalization. You don't have a normally healthy 30-year-old woman come in who's never been in a hospital with a resistant urinary tract infection that's moved to her blood. Where did she get that organism from?
This problem caught the attention of a genetic researcher who had a theory about where some of these infections could be coming from.
So this is the meat section, and this is where our team spent a good part of their year last year buying 2 packages of every brand of chicken, turkey, and pork.
No expiration.
This is chicken. I want to get some organics, so I'll get 2 of these organics.
Lance Price started sampling the meat supply in Flagstaff in 2012, trying to figure out if resistant bacteria from farms is ending up on the meat we buy.
We started this study because we had this hypothesis, this theory that food could serve as a source of E. coli that then went on to cause urinary tract infections. Could I get 2 pounds of the ground turkey, but could I get it in 2 separate packages?
Price isn't concerned with the trace amounts of antibiotics that could be in meat. He's looking for antibiotic-resistant bacteria that could be on the meat and cause dangerous infections if they end up on our hands or kitchen counters, or if the meat isn't cooked enough.
We're producing 9 billion food animals. And by using antibiotics in food animal production, we're creating drug-resistant pathogens that can then go on to cause drug-resistant infections in you and me. And
These guys expire on the 6th.
the problem with urinary tract infections is that if you get a bladder infection with E. coli and it's antibiotic resistant, and the doctor goes to treat you, and that treatment fails because the bacteria is resistant, then it can get in the kidneys. And once it's in your kidneys, it has access to your blood, right? And so then you can get what we call sepsis, which kills 40,000 Americans each year.
Hey, thanks a lot. Thank you. We're going to put it into a broth. We're going to put it in the incubator, and we're going to see if we can grow E. coli from it.
What Price wanted to know is whether the meat aisles of Flagstaff supermarkets were the source of some of the dangerous urinary tract infections that were showing up in the local hospital. His study would take several years. The widespread use of antibiotics on farms goes back decades. They were first used on animals in the 1940s.
Among the many valuable new products created in agricultural laboratories are mass-produced antibiotics.
It was at a time when agriculture was really changing and really becoming much more of a, at that time, it was not a pejorative, but it was an industrial model. So farms were getting bigger. Animals were getting put closer together. When you put the animals closer together and have them confined, then it's a lot easier to pass diseases back and forth. Giving them a little bit of antibiotic sort of seemed to fix that problem and sort of put a Band-Aid over it anyway.
But there was another benefit, one they had not anticipated.
The power to promote growth. Note the weight of a chicken raised for 8 weeks on a regular feed. Now another chicken nourished for the same period on regular feed plus terramycin, a 15% increase in growth.
They had discovered that if you add these drugs to the feed of animals, they were very useful in increasing the productivity of the animal. They kept them healthy. That was the main thing. They reduced loss and sicknesses in their animals. And they also discovered that it gains the same amount of weight on less feed. Feed is a very big cost.
Once something special for Sunday dinner, chicken, inspected and graded, is now thrifty every day.
People don't realize how expensive chicken used to be.
So antibiotics helped us get to inexpensive chicken.
Inexpensive and higher quality chicken. Yes, higher quality chicken. And pork and beef as well.
With the help of antibiotics, American meat production has tripled over the last 50 years. But with the growth also came concerns. As early as the 1960s, the British government sounded an alarm in a study called the Swan Report.
This was a milestone report. They said that antibiotics shouldn't be used to get the animals to grow faster because one of the unintended consequences was antibiotic resistance. Yes, it was economically short-term good, but in the long term, antibiotic resistance was a real problem.
But the report did not establish a direct link between farm antibiotics and human illness, and that's still the question today.
I'm not saying that, the use in animal agriculture doesn't contribute to resistance at all. Of course, we see resistance in veterinary medicine from the use of antibiotics. But there's a lot of unknowns as well. We really have not shown that direct pathway from you gave this animal that drug and some person somewhere down the line ate meat from that animal and they now have a resistant infection because you gave that drug way back here.
In central Pennsylvania, I came across researchers tackling this scientific challenge in a different way. They're trying to track how resistance might travel through the environment, from farms to people.
We came to central Pennsylvania for this research because there are a lot of swine animal feeding operations here.
Joan Casey is an epidemiology fellow at the University of California at Berkeley. 5 years ago, when she was studying for her PhD, she became interested in antibiotic resistance.
I've basically just started reading about it and trying to find out what was known about antibiotic use and farm animals.
Casey found research from Europe suggesting that an antibiotic-resistant bacteria called MRSA, which can cause deadly skin infections, was traveling from pig farms to people. She wanted to know if the same thing was happening here.
If people living close to huge animal feeding operations were at risk for getting infections from these operations.
To try to answer that question, Casey turned to Geisinger, one of central Pennsylvania's largest healthcare providers, where she joined forces with Brian Schwartz.
Almost 4 million people live in this region, right?
As a senior researcher, he had access to a trove of medical data.
We're able to get about 160 million electronic records on about 450,000 patients from the region.
And what'd you find?
Total MRSA from 2001 to 2009, straight up.
Wow.
Incidence up every year.
They found MRSA infections had been rising as much as 34% a year in central Pennsylvania. And the patients weren't typical.
People are getting MRSA who are not like the ones who used to get it. They're not old, sick people. These are young, healthy people.
And when they compared that data with the location of pig farms in the area, a pattern started to emerge.
This is the location of where all of the people with MRSA infections live. Each red dot is a person that had a MRSA infection. So these are all their home addresses.
Right.
So what I can show you here is the location of the swine operations in this region. Each of these barns represents a large confined animal feeding operation.
So let's look at this next one.
Yeah, so let me show this to you.
So what is this?
So there's some nice overlap you'll see between where the MRSA cases are and where these large swine farms are. You can see that there's some people with these infections living very close to animal feeding operations. And this is the only study that's really been done in the United States that's looked at rural areas and MRSA infection.
Their theory was that the MRSA causing some of the infections was coming from pig manure.
Every year in this area, there's about 600 million gallons of animal manure spread onto crop fields.
When you have antibiotics in animal feeds, the manure is loaded with undigested antibiotics. It's loaded with antibiotic-resistant bacteria, and it's loaded with the genes that the bacteria can transfer back and forth to each other that allowed them to become resistant.
But help me understand, how does it get from being put on a field as fertilizer for crops to threatening me living in my house?
So you put the manure on that crop field, and it doesn't rain for a month. And the soil gets dusty, and a big wind comes by. it goes airborne. It can travel by air. Or, conversely, a big rainstorm comes by and all the MRSA gets washed off into the drainage off of the field and into the local streets and onto the neighbors' lawns.
We actually found that people living closer to these farms and to the crop fields that are located nearby were about 38% more likely to have a MRSA infection than people living farther away. Right now, I think the best hypothesis that we have is that it's coming from industrial agriculture.
But to the farmers and drug makers, the study was just more unsettled science and speculation.
Well, I think the study was very interesting, and it showed some associations. But I think the implication is that antibiotic use somehow caused the problem, and there's no evidence that that is the case. They didn't test any of the manure, so they have no data on what was actually in the manure. So their study was more speculative than anything.
Why didn't you just take a trowel and dig up some of that crop field where the manure was and test it yourself as part of the study?
Well, it costs a lot more money, and we didn't have the money for that. And you also need permission to go on people's crop fields. And in general, getting access to the farm operations has not been easy.
In the end, though, aren't you really speculating about the link based on a pattern?
We have not made any definitive links, but I think there's mounting evidence that there's a problem.
Making sense of the science isn't easy. I went to the CDC in Atlanta, where they closely track antibiotic resistance. Is it possible that the use of antibiotics in animals is breeding resistance? That farms like hospitals are becoming a place where resistance comes from?
Well, it's not only possible. I mean, it's happening. I mean, we see resistance in pretty much everywhere and everything we test. So there is a certain amount of resistance in cattle and pigs and chickens and humans and the retail meat that we buy in stores. Anywhere you use antibiotics, you're going to have resistance and propagate resistance.
Yet the CDC acknowledges the lack of conclusive science.
It's very challenging to link the use of a particular antibiotic in a particular herd of animals to a particular human illness. I mean, that is really the challenge. So going from point A to B to C to D to E to F, tracing that bacteria all the way to person A with resistance A. I mean, that's very challenging to do because there are lots of steps in between.
The agency with the authority to regulate antibiotics is the Food and Drug Administration. Inside their archives, I found the story of how the agency tried to reduce the use of farm antibiotics nearly 40 years ago. It was 1977. The FDA had a new commissioner, a Stanford biologist named Donald Kennedy.
Members of my staff got some documents to me that convinced me that we really had a difficult problem to deal with. Livestock had been dosed up just to make the animals put on weight faster.
One of Kennedy's closest aides was Tom Grumbly.
He had passion about this issue, almost from the beginning. And the way he would express it was, look, I don't know whether antibiotic resistance is going to come more from the human use of antibiotics or from the animal use. But I know that there's really no difference.
Based on the advice of top scientists, Kennedy proposed restrictions on two of the most widely used farm antibiotics, penicillin and tetracycline. He feared that by overusing these drugs, farmers were fueling antibiotic resistance and threatening the health of people.
We're creating resistant organisms that may ultimately transfer that resistance to organisms that cause human disease.
I thought we were doing exactly the right thing. The trouble is that you don't always find that as easy as you would hope.
Opposition to the proposal was immediate. Farm lobbies and industry groups attacked it as theoretical speculation and said it would be financially ruinous. One of the most vocal opponents was the animal drug makers group, the Animal Health Institute. AHI was against that at the time. Do you remember why?
Well, I wasn't at AHI at the time, so I don't know. And you say that they were, but I don't know that they were. I mean, is there some documents that you've seen?
There is. This was actually AHI's proposal at the time, to the docket. AHI said that the commissioner's proposal is wholly illogical, would result in an arbitrary and capricious and thus illegal regulation.
I think in the case of penicillin and tetracyclines, it was a theoretical concern. Back then, they didn't really have good risk assessment at the time. They really couldn't put the whole picture into place as to, okay, this can happen. We know it can happen in the laboratory. Does it happen in the real animal? And what is the real risk to public health? I think that was where they were missing the data.
The industry turned to their allies in Congress, and one of their closest was Mississippi Congressman Jamie Whitten.
His informal title was the Permanent Secretary of Agriculture, a title he held for several decades.
Whitten chaired the subcommittee that controlled the entire FDA budget.
We were at the mercy of Representative Whitten, who basically made it clear that unless we got much more scientific evidence, he was going to cut the heck out of the FDA budget.
So he said that unless you guys would study this and get more information,
he was going to cut the budget.
And that's a pretty serious threat from Whitten, right? I mean, he's a powerful guy.
That was no threat. That was no brag. That was truth. He would have.
The proposal was shelved. When you proposed this in 1977, it wasn't settled science. You said you were confident about it. And I just wondered, did we know enough?
I think there was a search for what we used to call the smoking gun. That is, a particular antibiotic carried over and so forth. I think it was vulnerable enough to the argument that you haven't really shown us the smoking gun, that it failed in its time.
So after you tried and pushed for this and then it got blocked, did anything ever happen?
Well, it kind of went into the deep freeze for a long time. You know, people basically just said, you know, this is in the too hard category. And until we get real evidence or evidence of people, I hate to say it, dropping in the streets, so to speak, from antibiotic resistance, that nobody's going to do anything about this.
But there's new evidence emerging that FDA was onto something back in 1977.
Hey, good morning.
On a North Texas feedlot, I met two veterinarians who have spent years working with the cattle industry.
Guy and I have been working together for the last 10 or 12 years on many of these issues, actually.
We've done multiple projects on antibiotic resistance. We've been working extensively on this and making progress. It's evolving progress, but we're making progress.
Guy Lonergan of Texas Tech University and Morgan Scott of Texas A&M noticed something unsettling in their research with cattle. An important antibiotic called cephalosporin was losing its effectiveness. Bacteria were becoming resistant to it. So when the cattle got sick, they were harder to treat. But the scary part was that unlike most farm antibiotics, cephalosporins are critically important to humans too.
Okay, they're so critically important because there are certain types of infections for which they are one of only few choices available to treat these infections. I'll give you one example. So clinical salmonellosis in children and in many cases pregnant females are limited. Some drug classes can't be used.
So they're very valuable for children.
Valuable. Yes.
Yes. Okay, well, let me grab a bit of dry.
To try to save cephalosporins for both animals and humans, they designed a novel experiment. The idea was to use more tetracycline, an older drug less important to people, with the hope of reducing resistance to cephalosporins.
Good. Well, let's go sample.
All right.
I see. So you were hoping to essentially play a little bit of a game here, that by using one antibiotic, which didn't have big consequences for human health, you could preserve and protect one that was important for human health.
Exactly. Most of the world doesn't care about tetracycline resistance. They care a lot about cephalosporin resistance. Okay. So obviously, I think you're going to want these, and I'm going to want them too.
Thank you. And the lid should be there in the cup as well.
It was cutting-edge science, but it started with a plastic spoon.
We collected fecal samples directly from the animals, and from those fecal samples, we grew generic E. coli. We'll put the samples in the cooler ready to send.
So we're going to ship these down to College Station to do the microbiology work.
When they took their samples to the lab, they got a big surprise.
It was like, okay, this isn't going the way we thought it would.
We actually saw that resistance went up, which was not what we hypothesized.
Resistance went up to cephalosporins, the drug they were trying to save. And this is what the FDA had been worried about in 1977, that the use of tetracyclines could accelerate the overall spread of antibiotic resistance.
Our viewpoint historically has been that, sure, tetracyclines aren't that important for human health, so why worry about them in animal agriculture? But they may be more important than we think, not because of their use in human medicine, but because they can expand resistance to critically important drugs.
We did it for an entire year. So
Back in Flagstaff, Arizona, Lance Price was closing in on his search.
see whether there's E. coli in these foods and whether they have drug-resistant bacteria in them.
He and his team had spent a year going to supermarkets.
That's a lot of chicken.
Yeah, that's a lot of chicken, turkey, and pork.
I think that's it. Let's go.
And this is the micro lab. This is really the heart of our food operation. So we'll first have you gown up here.
At the lab, they'd been testing the meat looking for traces of dangerous E. coli.
Right, so what they've done is they've taken, a standard frozen turkey, and these were actually purchased over Thanksgiving, and then culturing the bacteria, the E. coli. When we say that there's E. coli on a turkey product like this, we want to know that it's definitely E. coli, and we want to know if it's the E. coli that can cause bladder infections or kidney infections or blood infections.
20% of the meat they tested had this bad E. coli on it, and a third of that was highly resistant.
So this is an E. coli from the food supply, and it's resistant to 5 different antibiotics. So it's resistant, 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 resistant. So that's 5 different antibiotics that a physician can't use to treat an E. coli infection. Wow.
But what Price really wanted to know was whether any of this bacteria had caused those urinary tract infections at the Flagstaff Hospital.
This is where we grow bacteria from patient specimens. This is a person that has gram-negative bacteria.
So he got the hospital to send him more than 1,200 samples of urinary tract infections they'd collected from patients.
So this is where we've stored all of the samples that we've collected from this study, including thousands from the food supply and thousands from urinary tract infections that we collected at the hospital. We have these tubes, and we said, okay, let's look at the DNA from the E. coli from the people. Let's look at the E. coli from the DNA from the E. coli and the food supply and say, are these matched?
By using state-of-the-art whole genome sequencing, he compared the samples he got from the hospital with the bacteria he found on supermarket meat.
So this is all the E. coli that we got from the food supply and from urinary tract infections in Flagstaff. So what the computer's doing right now is it's figuring out how these things are related to one another.
Price is only halfway through his study. It has yet to be peer-reviewed, but he let us in on his preliminary findings. So far, he says he's genetically linked more than 100 urinary tract infections back to supermarket meat products, and a quarter of them were resistant to several antibiotics. For Price, this supported his hypothesis that some of the dangerous urinary tract infections were coming from the food supply.
So here's evidence that these E. coli, the E. coli in the urinary tract infection, the E. coli in the food, came from the same original E. coli population, so probably the farm.
Probably the farm, but you don't really know how it got there, right? That's a bit of a guess.
When we see this, when we see such genetic relatedness like this, the alternative explanations become, impossible.
But even with the high-tech genomics, Price still can't make all the connections. That's because he doesn't have any data on how antibiotics are being used on the farm. I was surprised to find out that farmers aren't required to report how many antibiotics they're using or for what purpose. So we don't even know how many antibiotics are used on turkeys as compared to chickens.
No, we do not.
And we don't even know really the volume that's used for humans as compared to animals. It's a guess, right?
Not really, because the data that we have is based on drugs that are being sold, not used, or how they're used.
I mean, ideally, what data would you want to know? You're tracking resistance.
I think we've been clear for years, all of us, meaning the whole of government, academics, anyone who's tracking foodborne infections, that we would like use data. To be able to understand resistance and where it's coming from, it's going to help a lot for us to have better use data so that we understand how these antibiotics are being used and where they're being used. I mean, it's just not available, and it's not something that we collect. I mean, that's not our area, as was mentioned. You need to talk with FDA.
The FDA commissioner is Margaret Hamburg. Why don't we have that information? I mean, antibiotics have been used on the farm for 4, 5 decades. Why don't we have it now?
You know, for me, the question is, can we get it now? And that's what we're working on. I think it's a question of us all working together to identify what are the critical data needs. And
don't you know that now, though? 40 years? I mean, shouldn't you have a better handle on that, what data you need?
Well, you're asking a very big question in terms of the overall picture. We are focused on certain aspects of this challenge.
Last year, there were proposals in Congress that would have required farmers to report in detail which antibiotics they're using on animals and how much. But industry groups, like the National Pork Producers Council, opposed those efforts. Did you lobby against those amendments?
Those amendments did not have a lot of support among Congress. There was not really a need to actively lobby against them.
But you did not want those amendments to be part of that bill.
We did not think they'd be helpful.
What's to be afraid of with getting more information?
The people who were asking for that information are people whose motives were to restrict antibiotic use.
So you saw this as a way to get restriction, not just information?
Correct.
The proposals died. And after years of inaction, the FDA tried a new approach last December. It asked the pharmaceutical industry to voluntarily stop selling antibiotics that are intended only to make animals grow faster.
We actually believe that by taking a voluntary approach, we are going to move towards our goal of getting these antibiotics out of use for growth promotion in a more effective and speedier way than if we actually tried to go drug by drug to pull them from the marketplace.
The drug makers agreed to phase out these so-called growth promoters over the next 3 years. And the FDA will require greater supervision of all antibiotic use by veterinarians. Industry has told us that only 12% of the antibiotics that they sell in agriculture are used for growth promotion. So does that really mean that 88% of what's being used today will continue to be used?
The action we're taking is one step, but we clearly need a comprehensive strategy in terms of animal health and farm practices as well.
More than's being done today.
Oh, I think, we view what we're doing as part of a broader process.
I think FDA is very cautious, and because of the history that they had in the 70s where they tried this big step and Congress told them no, I think FDA is taking some baby steps. I think they could be much bolder.
I mean, we know what they're going to do. They're going to do this voluntary thing, right? But if they're not collecting the data to verify that people are changing the way they're using antibiotics, that the program is working, what's the use? How do we evaluate the success of this program without collecting data?
It's been nearly 40 years since the government first tried to limit the use of antibiotics on farms. Has anything really changed in those 40 years?
Yeah, the use of antibiotics has gone up. And certainly the problem of antibiotic resistance in human beings to drugs has gone up substantially.
We live in a shared environment. Bacteria that we can find in animals, we can find in people. And bacteria that we find in people, we can find in animals. So the route by which they move between them may not be that important. But the fact that they move between the two populations is important.
For more on this and other Frontline programs, visit our website at pbs.org/frontline. Frontline's The Trouble with Antibiotics is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. Frontline is also available for download on iTunes.